Yeah, so guys, we saw that when you want to create a stream from a collection, you are given two methods, which is collection.stream or collection.parallelStream. And we mentioned that the first one, which is collection.stream, returns a sequential stream, which is you are going to process a stream using one thread. And we have another function called collection.parallelStream, of which when you call, you have a functionality to split the data source and process it in chunks, and each chunk will be allocated a thread to execute it. And obviously that is supported when you are in a multi-core environment. You see, today we have computers that are coming with multi-core processors. So if your system supports it, as we saw in our previous lecture, you will get that parallelism to process your stream. So now we're going to see that performance difference is very huge between those two, especially if your environment supports parallelism. So let's come. So I have prepared a code for you guys here. I'm just going to explain it quickly. So as you can see, we have a function that is static that checks whether a number is prime. If it's not prime, it will return false. If it's prime, it will return true. That you can do on your side. Then we have two other functions that processes quite a huge data source. So we see here we have a data source from 2 to 900,000. So what you are doing when you say long_stream.range_loss, it will create a stream for you. And that stream will be given this data source, data which is 2 from 900,000. That is the meaning of this. So now that you have that data source injected into a stream for you, what you now, we can just go to the documentation to read. It says returns a sequential ordered long stream from starting to inclusive to end by an incremented step of 1. So that is what it does for you. It will return a stream for you from this number to this number. So now that you have all these numbers put into a stream for you, a stream pipeline to be processed. So now what we do, we call isPrime. And as you can see here, we are using a method reference. We already explained method references. And we know that a filter method in a stream takes a predicate. And we know that a predicate has a method called test that takes one parameter and returns a Boolean. So if we come here, we see we have long predicate. It takes a parameter, it returns a Boolean. So that tells us that this isPrime takes a parameter, returns a Boolean, which is actually the case here. It takes a parameter, returns a Boolean. So it satisfies the definition of the functional interface method. It satisfies the definition of the method defined in the functional interface long predicate. Hence, it's able to work for you. The same goes for here. So these two are the same. The only difference is that the second one, now we are telling the runtime that we want you to give us a parallel stream. But this one, it's just a sequential stream. So if we come here, it will tell you that it returns a sequential stream by default. So it returns a sequential stream. But now we say, okay, make it a parallel stream rather. So now when we call parallel on here, that's when now we get parallelism. So that parallelism, we already explained it in our previous tutorials. So now what will happen is that the filter will filter out all prime numbers that are not prime numbers, and it will leave all numbers that are prime numbers into the stream. And when it's done, what we do, we count all those numbers that are prime numbers, and then we print to the console. The second is also the same. So that is it about non-parallel and parallel function. We get list of numbers or a stream of numbers from 2 to 900,000 for both parallel and non-parallel. Now that we have that, what we want to do, we want to check a performance time for each one of them to see if there's a difference. So we have a code here called timeIt.code. So even before I can check what code does, the minute I see that this thing is passes a method reference, it's already telling me that what code receives is a functional interface. So now let's check. What is parallel? Parallel is a method that takes nothing as a parameter and returns void. So we are likely to find that we don't know what is in code, but what we do know is that it's a functional interface and it has a method that does not take anything as a parameter and returns a void. That is it. So let's go to the code. Oh, we see it's runnable. So let's check if runnable has a method that takes nothing as a parameter and returns void. Let's check. Oh, we see it has nothing as a parameter, it returns a void. So now that means now that your method reference here call actually does not clash with the functional interface runnable. It actually matches it, all the rules. So we know that rather than doing this, we could actually do this. We could actually say it takes nothing as a parameter and it returns nothing. So parallel is a void method. So this is still legitimate code. But now the IDE will tell you that you don't have to do it like this. And then it says replace with method reference, which brings us back to this code. So now we have explained that. Let's see what our timeIt code does. So what we do, we take a runnable. Then when we enter this method, we start the timer. Then we execute the run method. So what it will do, it will execute the method or this method, which is a method reference. Because what you're essentially doing here, you are passing functionality as an argument to a method. So it will come and execute this method parallel, which is here. It will execute this method. Then when it's done, finally, you take the time at that moment, then you check the differences between the times that are taken. That's basically it. So let's run this code and see. So we see that when we start with parallel, we print parallel, the time taken, then we print non-parallel and the time taken. And let's see whether there is a difference. Parallel, it took this time 2.75 seconds. Non-parallel, it's still executing. See, it took 9.88 seconds, and the answer is the same here. So we have 71,274 prime numbers between 2 and 900,000. So if I was to now make this 9 million, you will see that the performance will even go a bit higher. Let's run it again and observe. So as you can see, even the parallel stream is taking a lot of time to actually execute. So what we can do, you can do that on your own. I can stop the execution. So what I can do rather, I can just say 1 million here, 1 million, and then I can just say maybe 1.5 million, 1,500,000. Let's just run it with this one. Hopefully we can get results a bit quicker. You see, okay, these are the numbers. It took 6.75 seconds. Let's see for non-parallel. Wow, so such a huge difference. So you see that for parallel, the number will always be the same. But for this one, we got 7 seconds. And see this one, 26 seconds. So that is why parallel stream will optimize your solution, because it divides your data source into chunks. Then it gives you that high performance.